Shalom and welcome back to Expert on the Spot. I'm Professor Sari from the Rakach Institute of Physics on campus Edmond J. Safra. Thank you for uploading all the questions to the website. I will now try to answer some of them. First question is from Tal about white dwarfs and black dwarfs. So Tal, as you correctly explained, white dwarfs are the end state of stars which are not too massive. So when a star finishes to burn all its nuclear fuel, it gets smaller in size, it contracts, becomes very bright, the surface temperature becomes high, and we call this form of residual star, or that end state of a star, a white dwarf. Now eventually this white dwarf continues to radiate, and since there is no nuclear fuel, it will eventually cool down and will become a black dwarf. However, the lifetime for the white dwarf is so long, it takes so long to cool, that we actually never see black dwarfs in the universe, because the universe is not old enough to have allowed the white dwarfs to cool. So in principle, you're right, we'll have black dwarfs. The black dwarfs, under certain assumptions, they live forever or for extremely long time scales, but even they haven't formed yet in our universe. Next question is by Isaac Fisher, whether we can turn one material to another, one element to another, and specifically can we turn lead into gold. Okay, of course everybody wants to do that, and it is actually possible. You can change the elements if you can change the nuclear structure. If you can add neutrons or protons, or take out neutrons and protons from the nucleus of the element, then you change the element itself. This process actually is happening inside stars. Stars mostly burn hydrogen into helium, and that changes the element from hydrogen to helium. Towards the end of the lifetime of the stars, you form heavier and heavier elements. When stars explode, you can even create elements like gold. You can do that in the lab, in nuclear reactors, or nuclear bombs. So yes, in principle it is possible to change the element by changing the nucleus itself. It's a very energetic process, so it's not economical to do it. But your question was on principle, and the answer is yes, possible. Okay, so now we have two similar questions by Emerald and by Aaron on the possibility of existence of life in the universe. Where can we find conditions that are right for life, and can we tell about a specific planet that we find if it has those conditions? Okay, so first, it's a complex question, because the conditions for life, we're not sure exactly what they are. But life as we know it, at least, have several necessary conditions. You need the right temperatures. For example, you need water to be liquid. You don't want it to be cooler than 0 degrees and Celsius and not hotter than 100 degrees Celsius. That dictates a certain distance from the star. Given the brightness of the star, you can tell where the planet should be in order to have those temperatures. That region is called the habitable zone, and indeed we're looking for planets that are sitting in the habitable zone. That's the first part. Second, if you want life as we know it on Earth, you need the planet to be solid, to have a solid surface that the creatures can stand on. You don't want to put them on Jupiter, where they will sink all the way to the center of the planet. So what we believe is that small planets of small mass, like the Earth in our solar system, are made mostly of solids. And it's only those giant planets like Jupiter and Saturn that are made mostly of gas. So we should be looking for a planet in the habitable zone, in the right distance from the Sun, and that has a small mass. And indeed, both these properties we can tell by telescope observations, which is what you asked about. One of the ways to detect the extrasolar planets is to measure the velocity of the star because of the motion of the planet around it. And if the velocity is large, it means that the planet is massive. If it is small, it means that the planet is less massive. So from the amplitude of the velocity, you can tell the mass of the planet. And it will tell you if it's small enough, likely therefore to be made of solid elements, and therefore to have a solid surface. From the period of the orbit of the planet around the star, you can tell the distance. So both these quantities, the period and the amplitude of the velocity, gives you information about the mass and the distance, which are the two things you need for the right temperature and for having a solid surface. So yes, we can do it. The next one is not actually a question. So Tamir, thank you for the warm words. And you're welcome to check my website for updates on my research. Thank you. Last question is from Gideon, and this is about my return from Caltech to the Hebrew University. So for me, that transition went pretty smoothly. The reasons for my return were multiple reasons, not directly related to better research at the Hebrew University, because my research conditions at Caltech were excellent. But the Hebrew University did manage to accommodate many of my research demands. There's always room for improvement, of course, but I would say it went pretty smoothly. The other reasons, the major reasons to return to Israel were actually family and the will to live in Israel. Okay, so this answers all your questions, I believe. Thank you very much for uploading them, and see you sometime soon at the Hebrew University. Thank you.